So today we're going to get started by addressing a couple of outstanding issues that we've just kind of been ignoring so far. So last week you might have realized that it's a little bit hard to save your code. And the reason for that is that we've been writing our code directly into the console. And if you've ever worked with another programming language, or if you've worked on other things that kind of go deeper into your computer, you've definitely worked through the console or the command line or the terminal before. If you haven't, then you've been doing that directly here with R. The console is good for running your scripts and doing a little bit of experimentation, but it's not good for writing a complex program that's going to need to reference other parts of the program. For that, you're actually going to want to write a script or create a file. So let's go ahead and get started by doing that today. You might have a little additional box up here that might be a file, but the surefire way to find the place to make a new file is to go up to the very top, click on File, click on New File, and we want to write a new R script. You see there's also a shortcut, so there's a Shift-Command-N. You might have a different shortcut there. That will give us a box here. This box is actually where we're going to write our code, and then it's going to run in the console, and then it's still going to give us the output over here. So it's just like what we've been doing in terms of these three boxes, but you're going to write your entire code here. This allows you to have a little bit more control over how much you're running at a given time. It also allows you to save your file more easily. So you can write a complex script that has multiple dependencies by using the files rather than the console. So if you're writing code that you care about or that you want to save, make sure that you write it up here in the file. And if you're just running a little experiment, you want to see if something works, then write it down here in the console. So today we are going to use a data set that we found on the internet. It's actually a pretty famous data set. It's the H-1B visa application data set. And this is a record of all of the H-1B visa applications by different companies in Q4 of 2018. It actually goes back quite a few years, but we're going to focus only on the Q4 data. And let's see if I can pull that up for you. Right. So this came from the Office of Foreign Labor Certification. You can download this data set here. There's also a couple of online databases that allow you to query the data set to extract specific pieces of it. But we're going to do our own selecting and querying from within our program today. So if you want to know more about this data set, go ahead to foreignlaborcert.doleta.gov to find more information about it. Otherwise, this data set is on the LMS. So I'd like you to go out to the LMS now and download it somewhere on your computer. I've downloaded it to a folder on my desktop, just so for easy access. To read our file in and to work with our file, we're going to use the tidyverse library. So the first thing that we're going to write up here in our script is library tidyverse. And hit tab there, and then I'm going to go to the next line, and I'm going to set my variable to H1B, because that'll be easy for me to remember as I'm going through and using this data set. Unlike in previous tutorials, we're going to use a different assignment mechanism. So we've been using kind of a shortcut so far, the equal sign. But within R, whenever you're setting a variable that you're going to refer to later on, or just pulling something in that you're going to use throughout your package, you actually want to assign that variable with this set of characters. It's the right-facing arrow and then a dash. And that will assign our variable to a function. And that function is going to be reading in our CSV file. So we're going to type read, and then it's going to help us as per usual. So if you hit tab, it'll autocomplete the read.csv. And then for most of the built-in functions with R, there's this incredibly helpful dialog box that pops up. So here we have read CSV, and then it tells us that the first argument it's expecting is the name of the file. It disappeared there, but the second argument that it's expecting is if you are using headers or not. So we are going to read in our headers, and that dialog box had told us that the default value was true. One way you can get that back is by just typing it again, and then it appears up here. The default separator is the comma. The default quotation mark is the backslash quotes. This is pretty common throughout other Markdown formats. The default decimal place is the period or the dot, rather than, say, the comma if you are using a European data set. The default fill is true, and fill means that it's going to fill in empty cells with not a number or not a value. And the way to comment out a character is with that set of characters there. Do not worry about that. We're not going to use it we're probably never going to use that. All right, so the first thing we need to do is tell it where to find this file. Now, if I type open quotes and then hit tab, it'll give me the list of all of the folders that R can currently see. And I've saved this to a folder on my desktop. What's going on here, you will definitely see a different set of folders. And what's going on here is that from wherever R is installed, it can see, quote unquote, a bunch of folders underneath it. So R probably was installed in your root directory, and there should be a whole set of folders of whatever is beneath it in terms of the file structure of your computer. So for me, it's on the desktop. If I hit tab again, it'll give me all of the options of things that are on my desktop. So I can go ahead and click any of these. It's in my INFO640 labs folder. Hit tab again, and it's in the datasets folder. I hit tab one last time. It's the only thing in the datasets folder. You might have something else, but for me that was the only one. If you do have more than one file in there, you'll go ahead and select it by just clicking on it. All right, so now that we have our file name, we're going to say header equals true. So we saw that this was the default, but we just want to specify it again just to show you how to set your options within your functions. So I'm going to say header is equal to true. And what that means is that I want R to read in the first row of data as the variable names. And understanding that the column headers are representative of the data that comes below. This is pretty standard practice, but sometimes you do actually have a CSV that doesn't have any headers, and you are going to specify the column names later. All right, last thing is that we want to know that this worked by the time when we run our code. So I'm going to say print out the type of this file. So I'm going to write type of H1B, and then it should tell me that the type of this variable is a list. Okay. All right, so now is the time to run our code. Now, R is a little bit clunky in this way, endearingly so. And in order to get your code to run in this interface, you need to select all of it. So I hit Command A, you can also hover and just select all of it. And I'm going to hit Run up here at the top. We'll talk about the shortcuts in a second. So we see that it is running. And down here you'll know that it's completed either because of the arrow or because you will get an answer to type of H1B. You might want to pause the video and wait for a second because the H1B dataset is very large and it's going to take a couple of seconds to load. Once your dataset is loaded, you should get the next row that says the type of this variable is a list. And if you have that, congratulations! You have loaded your first dataset from the internet into R, and now we can go ahead and start working with it. But before that, I really want to know what's going on in this dataset. So I'm going to ask R to give me a summary of what is in H1B. Now, you could select all of this code to run again, or you could just select this one line and then hit run. So if you select the line, it'll run that one line, and then it'll give you a really complete summary of what's going on in this data set. I was trying to make it all fit in one row, or at least more fit in one row, but that obviously is not going to happen. So let's go back up to the top here to see what's going on in this data set. The first thing that I notice is that there's probably about 650,000 records. Each one of these has a unique case number, which is why you see a 111 here, and then other. So what this is saying is there's too many unique rows, there's too many unique values within this variable to display all of them. So it's just going to give you the most common types. We can see this looks pretty good. We have mostly values here, but we have an NA as one of our most common types. And that's employer business DBA. I'm honestly not totally sure what that is. So it's probably not something that I'm going to want to filter on. Things that I am going to want to filter on are things like employer city, employer state, and probably pay, which is a whole lot further down here. Our wage rate of pay and our prevalent wage values are going to be really interesting to us. So we see here that there's also a whole lot of values. So I'm going to be kind of aware of that. I haven't really looked at this terribly deeply, but I do know that I probably don't want to open this up in something like Excel because it's going to crash my program. So let's get a better vision into some of the data that we're interested in. The first thing that we're going to do is try to get the mean of a column. We're actually not going to be able to do this. This is not going to work, so we're going to have to do a little bit of troubleshooting, but we don't know that until we try. So we're going to try to get the mean of the wage column, or the base wage column. So I'm going to type mean, and I'm going to pass it H1B and then $, and then I'm going to start typing wage, and this will give me all of the columns that have the word wage in their title. And I'm going to use wage rate of pay from. This is the base level of pay. And I'll hit enter. I know that that's a numeric value. I saw that numeric value up at when I was looking at the data, but if you run this piece of code, you will get an error. And the error is saying that this is not numeric or logical. You often get this error when there's something in your data that R doesn't know how to handle. So the way that R handles non-numeric values is it expects them to be NA. Not N/A, not applicable, nothing like that. It can only be NA. If it's something other than NA, R says, oh, this must be a character column, not a numeric column. So what we're going to do is force it into being a numeric column. So I'm going to set this column, I'm going to call it wage, and I'm going to say that wage is as numeric, as dot numeric, and then it'll give me the option H1B dataset. I'm going to select the wage rate of pay from column, and then now I'm going to try the mean again. So I'll type mean and then wage, and then I wanted to remove the empty values or the NA values, so rm.na, remove NA is equal to true. Okay, so now let's run these two lines and see what happens. Excellent. We get this number down here, 32,000. Now that seems a little bit low. I was expecting this to be a yearly wage, but there's a lot of different ways that wage could be calculated. It could be hourly, it could be monthly, things like this. And I know that in this data set, it is broken down by the frequency of pay. So we're going to have to account for that. So rather than working out how much hourly each person would make yearly, I'm instead going to subset my data frame by selecting only the yearly values. The way that we'll do that is with the subset function. So we're going to make a new variable, h1b yearly, and we are going to assign it to the subset of the h1b data frame, and this wage right, you have to actually know what it is. So it's wage unit of pay. And we're going to set that equal to year and run this piece of code. And then it'll take a second to load because what it's doing is it's going through and it's selecting only those rows where the wage unit of pay was year. All right, and now that we have our new data frame that only has the unit of pay in years, we can say our wage yearly is, and assign that variable to the forced numeric function h1b yearly, and then our wage rate of pay from. Okay. And then if we take the mean of this value, so the mean of wage yearly, and remove the NA values equals true, and then we go ahead and run this piece of code, we see it's at 32,000 still. So we know that there's probably something going on here that's not quite right. Let's check out what our minimum value is and see if there's something odd going on there. So if we go to the min of wage yearly and run that, we see that there's definitely a problem. $1 per year is not a salary for anyone. So there's probably some kind of issue going on. Without getting too deep into data munging and cleaning and all of this, we're just going to leave it here for now and say that the mean wage is 32,400. We will be coming back to this data set later in the semester in order to clean and transform it and actually get the data out of it that we want. But for today, all that we want to do is to be able to calculate the mean. The next thing that we want to look at is the median salary, which you can probably guess is very similar. You type median and then wage yearly, and then remove NA is true. And if we run this line, we see that the median salary is about 38,000. That also seems exceedingly low for what we were expecting. So we probably want to go in and look quite a bit more at this data set. You can anticipate that either A, some of the hourly wages were listed as being yearly wages, or B, there are some zeros left off of some of these wages. So like I said, we'll come back to this later in the semester, but for now, looking at our mean and our median has given us an idea that there's probably something wrong with our data. There's one more thing that I'd like us to look at before we close out today, and that's the distribution of these salaries. So I've gone ahead and pasted into here some code that will make a distribution plot for us. So let's read through this in order to get the distribution plot that you are currently seeing over there. Okay, so we are going to start by calling the ggplot library, as we do with all plots, and we're going to pass it the H1B yearly data frame. And we're going to say that the aesthetic, the X values, should be the yearly wage, that wage yearly variable that we forced into a numeric variable a little bit earlier. Close two sets of parentheses, that's 1 unit. All that that has done has specified our plot shape. We'll use that in a little bit more flexible of a way as we move on with the semester. So we're going to add to that a density plot, the geom density, specifying the geometry there, and give it the aesthetic of y is equal to ... count ... The ... count goes through and tallies up how many times each value occurs within the data set. So it does some calculations behind the scenes. We'll specify our fill to be light gray, just to give it a little bit of shading. Close out those parentheses. And we'll add to that a line type is equal to dashed, just so we have a dashed vertical line there. We'll then add a vertical line. This vertical line's aesthetic will be the x-intercept. It's just going to be a line going through the x-axis. And it's going to go through at the mean of the yearly wage. That's that 32,000 that we calculated earlier. We'll specify our type to be dashed, our size to be a very, very thin 0.3, and our color is red. So we'll go ahead and run that, and it takes a second to load. And it should come any second. And what we see here is our yearly wages. We have a peak here around 55, and we have a peak here around maybe, I don't know, 3,000. There's probably something wrong with that again, so we will look deeper into this data set, but it allows us to see that this is not a normally distributed data set. There's one really peak down here, and there's one peak over here. It's almost the opposite of a normal distribution, that there's something going on in the middle here where, you know, there's no values. So that should also give us pause. We can think of a couple of reasons that this data set might be distributed in this way, but ultimately we would want to see the majority of the values in the middle, or we would expect to see the majority of the values in the middle and then outliers out here on either side. So we should definitely look into this data set a little bit more deeply as we move on. All right, so that is more than enough for today. If you have any questions, feel free to ask me. For today, what I would like you to do is save your project. This will actually save the code that you will be able to use again, and save it with wherever you want to save it. What I want to see is your exported image. So please send me your plot that you have here using the export button, save as image. And I will see you next week. All right, take care. Bye.